Hello everyone. Today's topic is grade 12 Doppler effect. Under Doppler effect, we are going to be focusing mainly on the behavior of sound related to how you hear it. Either you are going towards the source or you are moving away from the source. So in Doppler effect, we have two formulas. In which these two formulas are going to be helping you to calculate the frequencies of either the source or the listener. The listener is maybe, let me say, where the sound gets to. For example, I can say that for you to hear someone calling you, you are the listener, and then that particular person is what you call the source. Source is where the sound is coming from, and then the listener is where the sound is getting to. So we have the formula for the frequency of the listener. When the listener wants to hear a certain amount of frequency from the sound or from the source, this is the formula we use. And then this one is when the frequency of the source. So now we say that the velocity, this V stands for the velocity of the sound in air, this velocity, and then its magnitude or its units is the V is always equal to 343 meters per second. So this is the speed of sound in air that the sound travels with in air. And then this is the velocity of the listener. Note that these two things, they are always going hand in hand. If here is the frequency of the listener, the velocity of the listener must be in the numerator. And then the plus or minus is the direction determining either you're going towards the listener or you're moving away from the source. So here also these velocities are the same, is 343 depending on if you are given the information, looking at the different locations. So, but the speed of light, the general one is 343 meters per second, where plus or minus is the directions in which either the source is coming to you or the source is moving away from you. The source we can relate it to maybe a police car, we can talk about ambulances, we can talk about traffic cars and all those. So this formula is when you want to calculate the frequency of the listener. For instance, it's you listening to an ambulance, the sound coming from the ambulance, the siren that is emitting the sound, that particular sound, that particular source, the siren, we are talking about the frequency of the source. And then we have another one where we are saying that the frequency of the source. When you want to calculate the frequency of the source, now this is the same speed as the speed of sound in air, and then this is the directions in which either you are coming or you are moving away, and then this is the velocity of the source. Note that the frequency of the source has to be in line with the frequency, with the velocity of the source. If you are calculating the frequency of the source, your velocity of the source must be in the numerator. And also, if you are calculating the frequency of the listener, the velocity of the listener must be in the numerators. So now, in looking at this is the frequency of the listener, and then this is the frequency of the source. Now let's look at the what is the names of respective variables there. We are saying that the frequency of the source is Fs. It's represented by Fs. That's the frequency of the source. The source, we can talk about what? We can either talk about the ambulance, we can talk about police vehicles, we can talk about traffic cars, we can even talk about the truck emitting the bell and hooter and all those. So this is the frequency of the listener, where now the listener can be you listening to the source or the sound coming from the source. And then this is the velocity of sound in air, in which we showed that is 343 meters per second, depending, but it differs with the locations on where you at. And then this is the velocity of the source, Now, the velocity of the source, in which is the velocity of that particular vehicle. The velocity of that particular vehicle, it can move with 20 meters per second, 200 kilometers per hour. So this is the velocity of the source. And then this is the velocity of the listener. You can either be running, walking, and not moving at all. So when you're not moving, the velocity, you know that is zero. When you're moving, the velocity is certain amount, and then if you are running, also it's still the same. So these are the interpretations of what we have in our formulas. And when you see VL, note that this is the velocity of the listener. When you see VS, this is the velocity of the source. But these ones are constant. This 343 meters per second, and then this is the thing. Now we are going to now focus on how do you see, or how do you calculate when you're moving towards the source or you're moving away from the source. And then we're going to show each other on how do we do all those ones. So now we are going to focus on the frequency of the listener. You have the formula for frequency of the listener, where we have FL equal to the V plus or minus VL over V plus or minus VS multiplied by the VS, right? So this is the frequency of the listener. But now I tried to simplify it in terms of taking it down and break it down piece by piece so that you can understand it. So this formula, this one, I'm speaking about what is inside, but remember that this is always multiplied by the frequency of the source. So looking at this information is telling you that the listener is going towards, this one is telling you that the listener is going towards the source. But remember that here it means that the source is moving away from the listener. The source is moving away from the listener, and then the listener is moving towards. It makes the whole frequency of the listener to become bigger, because the numerator, if it's bigger, then the numerator, if it's smaller, and then we are saying that the frequency of the listener is going to be bigger. So now let's look at this one. This one, look at these two signs. This is a plus, it means you're going towards. And then this is minus, it means the source is moving away. Now let's look at this one. As long as here is minus, it means that you are moving, the listener is moving away, and then the source here is moving towards the listener. So meaning that the numerator is going to be smaller than the denominator. If the numerator is smaller than the denominator, then the frequency of the listener is going to go down, because the frequency and this, they are inversely proportional. Now let's come to this one. This one, because I have a negative and negative, let's remember that we have a negative here, we have a negative here. It means that both of them, they are doing what? Moving away from each other. So which means now you are moving away, the listener is moving away from the source, and then even the source now let's look at this, right? So looking at this one, it means that the source here, also this number is going to decrease, right? So if the number is going to decrease, and then also the number here is going to decrease, let's look at